Thanks, everybody, and welcome to this edition of Down to Earth and Center for Science and Environment webinar. And as you all know, uh, this series of webinar is basically focuses on the most pressing development currently. And this time it's on climate emergency, as the name suggests. It is already an emergency. And that's why basically we'll be talking about one aspect of it and the most critical aspect, and I think which is being talked about a lot. And I am Richard Mahapatra from Down to Earth magazine, and I'll be holding this webinar. And let me introduce the context, setting the context to it. If there is a year which has to be put on record for breaking records, particularly the weather records, 2023 will be that year. Not a single day, a week, a month, and by end of the next month, that is this year. This year has been on the unbridled record-breaking weather events. And sometime it has happened like this, like the last cyclone. We are told that the cyclone changed its pathways so many times that we are not able to actually tell exactly where and how it's going to land. So if you look at it, it's a brewing, unpredictable, and what we call the uncharted way we are actually moving as far as the planetary weather conditions are evolving or happening. Just to give you one example, the warming this year till now, that's the on record. It has broken all the record. We are the warmest year, you can say, in 100,000 years. And as the World Meteorological Organization says, the whole planet actually experienced a heat wave this year. And there is still no respite from that. And in India also, it is also same. And you will get to hear from the next speaker about how many extreme weather events have hit the country. And there are also changes. So the emergency is definitely there, and we are not able to comprehend this. You can call it the new normal. I think that's the better way to accept it, saying that there is a new normal or a new normal. And just to give you a statistics that recently the World Meteorological Organization again said that by 2030, it means in the next 7 years, every day we'll have two extreme or large scale disaster events every day. That's 560 per day, per year. And that's the kind of situations we are actually entering into it. And this is, in this context, what's being spoken about, what is being actually very in an urgent way. What can you do in this new normal scenario? So that brings the early warning system into focus. How can we all be covered with the early warning of the disaster that striking us, so that at least we have the little bit of time to plan and to escape? And that's being spoken about in a large way. Now it's the, if you go by, the world has a target by 2027, it means the next 4 years, we promise ourselves that each of us in the planet will be covered with early warning service. It means giving us a bit of early warning about a disaster to strike us. So that's the way actually you can actually adapt or can escape this new normal situation in this climate risk planet. And why you need an early warning? What we have seen that of late, disasters are increasing, and as you know, disasters actually hit the most vulnerable and the poorest and the marginalized the most. For example, the poor and developing countries are hit the most casualties wise and damage to properties. And if without an early warning system, a country would be 8 times more mortality from a disaster than a country which has some early warning coverage. So that's why the early warning system or getting a coverage of a early multi-hazards early warning system is very critical and very fundamental way to actually escape or to prepare a bit to reduce. But said and done, this is also a something that's a big, you know, to cover the whole planet. Everybody on the planet is promised under a early warning system, but it's also essential now. So on this, just to give to the other things, if you look at it where we currently stands, 50% of the countries in the world don't have a coverage of a early warning system nationally. So it means in the next 4 years, that's by 2027, we have to actually bring the rest of the countries in the world under early warning system. Effective, giving you that message, that SMS or on any platform, the message that is disaster is going to strike you. There will be a heat wave, there will be a cyclone, there will be a storm, so that you prepare. And what, as I already told, we have seen that early warning and this small step and giving a early warning to an impending disaster can reduce mortality as well as damages to properties and can economically we can insulate ourselves a bit in the climate risk planet. So saying this now, let me introduce. We have a very power-packed speakers here who bring their respective and those who are already working on it. We have Rajit Sengupta. Rajit Sengupta comes from Down to Earth magazine, and Down to Earth and CSC runs that they monitor the disasters every day and come out with two reports every year called the Atlas, the Climate Atlas of India. So Rajit will be giving you the what has happened till now. Then we have Akshit, who is a correspondent with Down to Earth magazine and was just led the cover story on early warning and the disaster and climate change scenario for Down to Earth, and he will just take you through what we have found. Then we have Dr. Parthasarathi Mukhopadhyay, who is a senior scientist with the Indian Institute of Tropical Meteorology, Pune. We all know him, these institutions. He has worked extensively on the monsoon and the forecast and how to actually early warn things also. Then we have Dr. Giriraj Amarnath from International Water Management Institute. Is joining us from Colombo, Sri Lanka. And he is known, at least for us, we have been always saying that this integrated drought management systems and also the flood early warning systems. And Dr. Amarnath is the first call. Always we make the first call to get a immediate insight into things. And this is where the four speakers are there and will actually take us through it. So now I invite Rajit. Rajit, it's yours, but in 10 minutes as an emergency.
Thanks a lot, Richard. I've just run through. So, is my screen visible to all?
Yes, yes, Rajit.
Yeah. So, 2 years back, we started a database called India's Atlas on Weather Disasters. What we do over here is every month we are updating the database, and what we look at the metrics is how many days some part of India has experienced an extreme weather event. So we are looking at it in terms of how many days extreme weather events have rocked India. And accordingly, what we have also looked at is we have looked at the number of disasters that have happened, number of loss and damage that is happening in terms of the human deaths. And also we have looked at the number of cropped area that is being affected, and along with that, how many livestock has been affected and how many houses have been affected. So we look at the loss and damage, and we look at the number of days when extreme weather events have happened in India. For the past 2 years, we've been tracking it. So today, what we're doing is we are going to talk about, is my screen being shared right now? Is my screen visible?
Yes, Rajat.
Yeah. So, yeah, I'm terribly sorry for this. So basically, I'll quickly take you through how we get our numbers. So there are three sources that we looked at for this database. We look at the IMD, the Indian Meteorological Department. It basically comes up with a monthly update on extreme weather events. So we use it to ascertain what are the extreme weather events that have happened in India. Then the Ministry of Home Affairs, it comes out with something called a situation report, which usually this year it started at about April. And during the monsoon season, every day it comes out with this report. And it also has a cumulative number in terms of loss and damage that has happened because of the extreme weather events. So we look at IMD for the events. So we look at this disaster management division situation report for the loss and damage that has been triggered due to the disaster. And finally, we also look at media reports to see if other events have also happened. So my estimate is around 80% of the entries that we have in our database is through the government sources, and around 20% is through media reports. And usually events like cloudburst and all is not very well covered in the government sources. So we look at media reports for the same. So what we have done this year is we have looked at the period between January 1st, 2023 to September 2023 again. So the first 9 months of this year. And what we found is that we roughly had a disaster every day. Some part of India had an extreme weather event every day, which basically dispels the traditional idea of an extreme weather event, which is like a once in a lifetime kind of an event for which about which we talk about for years and together. What we are seeing increasingly is that extreme weather events are becoming more frequent and they become very rapid. They come, they hit you, and then they leave. So what we found is that out of the 273 days between January and September this year, 235 days, some part of India experienced an extreme weather event. So that is one thing that we realized. So almost a disaster a day. Then we also found that all 36 states and union territories reported extreme weather event on at least one day this year. That basically means that all parts of India are vulnerable. Obviously, some portions are hotspots and some are less vulnerable. However, all states and union territories had reported at least one day of extreme weather event this year. Madhya Pradesh recorded the highest number of days with extreme weather events. That is 138 days out of 273 days, followed by Uttar Pradesh and Himachal Pradesh. So basically, these are the three states that had the maximum number of extreme weather event days. And 6 Indian states had more than 100 days of extreme weather events this year. So basically, out of 273 days, at least on 100 days, there was some form of weather disruption that these places experienced, big and small together. Then, if you look at what kind of extreme weather event and that rocked was, the most common is lightning and storms. Lightning and storms. So these classifications of extreme weather events have been taken from IMD. So lightning and storms this year we saw. Hailstorm was one event that was very common this year. So out of the 273 days, on 177 days, some part of India had lightning and storm event. On most days, there were multiple states that reported it. And then followed by that, we have heavy rains, floods, and landslides on 132 days, heat waves on 49 days, which was very low compared to last year. And we have cool waves on 21 days. And this, I think, is snow and other events. So if you look at the graph at the bottom, what the graph shows, so the color is coordinated with the extreme weather event type that happened. This is from January 1st till September 2023. And each of these bar is the individual day of the month. So we've got 273 bars over here. And the height is the number of states that were affected. So if you look at this one, on this day, whichever day it is, more than 20 states had some extreme weather event that was reported. And it was basically heavy rains, floods, and landslides in most of them. And some of them also had lightning and storms as well. So basically, this shows you the amount of reach in terms of states and UTs which are getting affected. So if you look at it, July, August, and around 15, some days around 15 to 20 states and UTs have been rocked by some form of extreme weather event. So what we saw is that for 122 consecutive days from June till September 2023, so starting from here till here, we had extreme weather events at least reporting from one place. In fact, on most days it was more than one place, which you can see by the length of the bar over here. And finally, what it entails is, what we have found is that all of these extreme weather events that have happened, they've led to at least 2,900 deaths, human deaths this year. With Bihar being the worst affected, 642 human deaths have happened. Himachal Pradesh is 365. Then it has also resulted in crop loss. So 1.78 million hectares of crop loss, cropped area has been affected. So this is not really the crop loss number. It is basically the area which is under agriculture, which has been affected due to extreme weather events. So Haryana has the worst, and states unknown is basically a big chunk, which was basically multiple northern states were affected due to hailstorms. So we don't know exactly what is the breakup. So we have states unknown over here. Haryana, Punjab, Himachal Pradesh. So this also has UP in it. I know for a fact. So there were 3-4 states that reported it. And then finally, animal deaths. Again, Punjab is featuring right at top. So it basically shows you that there's a lot of human deaths. It is affecting our food security because crop area is being damaged. A large amount of crop area is damaged, and it also shows that livestock is also being affected because of this. So we, in this database, what we're looking at, so this is how the database looks, and this is basically the link to it. We update this database every month. What you can do is, you can look at the state wise, you can go month wise at the top. If you see over here, this is basically a counter for the month wise update. And you can also jump to 2022 if you want to have a look at it as well. So you can find your own stories over here. So Richard, I'll stop over here and over to you.
Thank you, Rajit. Basically, to sum it up, if you look at it, I think the two sectors that suffered the most damages, that the crop and the livestock are also the two life crutches for maximum number of people in the country. At least 60% of population actually depend for survival on agriculture and livestock. And that's why I think this year, when we are talking about persistent food inflation, we are also talking about the extreme weather events, whether from Reserve Bank of India to the Ministry of Finance to anybody. They are saying that this time it's actually rampant, and the food inflation is happening. And food inflation is happening means we are also heading towards food insecurity, because affordability, people no more afford food, good diet, and that's the global situation also across the world. The same situations. We'll take all the question answers at the end of the sessions. So now I request Akshit to join, and Akshit, as usual, you have also 10 minutes before we go to Dr. Partha Sarthi and Giriraj. Akshit.
Sure, sir. Sure, sir. I'll take over from here. I'll share my screen. Uh, screen is visible to everyone. So visible and invisible.
Yes, Akshit.
Yeah. Talking about really what's happening in the world, we in temperatures and extreme weather. I'll also be taking you through our stories that we did.
Akshit, so sorry. Can you come a little closer to the screen?
So
Also, can you close your camera? I think there's an internet problem. Can you also switch off your camera? That will increase the. It's breaking in between. Yep. Can you? Thanks.
Okay. Yeah. So I'll be talking about the basic things that are in terms of rising temperatures, rising average global temperatures around the world, and intensity and frequency and changes that are happening in weather events. And that then I'll be talking about that we found in terms of extreme weather events and early warning systems for these extreme weather events, and how to know about them, and what is being done right now, what the challenges in designing and implementing these early warning systems, and what in the future. So this is basically down to earth covers on early warning systems. It basically tells you the story of how recent have happened, and how warning systems failed in those, and how extreme weather events forecast predicted, and early warning systems should be designed for these extreme weather events. And so 2023 is the hottest year since pre-industrial times. If you go back around 100,000 years, it would be perhaps one of the hottest years on record in the past 100. And the many months this have have had temperature records broken around the world. It was the northern hemisphere which was going through its summer during July, August, and September, or it was including Africa, in South America and Australia, which going through their winter season. So both those hemispheres have been expecting, have been temperatures of year. They have been broken. July was the hottest month since pre-industrial times globally. Many months, the last 3 months, basically July and September, have crossed the temperature threshold of 1.5 degrees temporarily. It doesn't mean that we have crossed global average temperature, or the temperature of 1.5 degrees Celsius that has, but these events, if these monthly records, if these average annual records are broken regularly, then we get much closer to breaking breaching the 1.5 degrees Celsius target in the Paris Agreement. So 2023 is most likely to become the hottest year on record since pre-industrial times, and perhaps in the last 100,000. Record sea surface temperatures and waves all around, including in places that usually record marine waves, for instance, which have seen very unusual storms in this year, which have generated certain wind systems have been unprecedented, and which generated rainfall that have basically in many countries. Apart from that, there has also been record low sea ice extent in Antarctica. It's unusual because usually to hear the Arctic with record low sea ice extent. Antarctica till now, at least, has been stable, but it has been seen, scientists have that there has been record sea ice extent in Antarctica, and this has contributed to basically much warmer than normal sea temperatures around the Arctic, around the Antarctic. So this has a combined impact of El Nino, which is a global phenomena, which is a natural global phenomenon, happens in the equatorial Pacific Ocean, but it has come on the back of which has been happening for the past century and a half, and now scientists are very clear about this fact. El Nino, the impact of El Nino are when global warming is also happening, and these impacts are being enhanced, and temperatures, that is why all these temperature records are being broken, both during the summer season in the northern hemisphere and in the southern and in the winter season in the hemisphere. This global average that are rising, increasing moisture content in the atmosphere, and there are changes in the atmospheric systems and oceanic systems which are being closely followed but not completely understood by them. And the characteristics of extreme weather events. This includes extreme rainfall, flash floods, landslides, tropical cyclones, heat waves, wildfires, and droughts. There have been flash floods in the past few months in Europe, and these flash floods have occurred mainly because of uncharacteristic storm systems that are formed both in the North Atlantic Ocean because of extreme sea surface temperatures, in the Mediterranean Sea, extreme sea surface temperatures. So these uncharacteristic storm systems have not only unusual in Europe, caused flash floods in Spain, Portugal, and Bulgaria, in Istanbul, in Turkey, but also they also caused devastating floods in Libya in September 10. It happened because of this storm system, which was called Mediterranean Daniel. Mediterranean is basically like system which forms in the Mediterranean Sea, and which are they have been increasing in frequency due to global warming and rising sea surface temperatures. And this particular was made 50 times more likely and 50% more intense due to climate change. Scientists have actually found from the World Weather Attribution. They also led to the collapse of two dams which were built in 1970s. The fact that these countries like ready to adapt to these extreme events and actually create or design early warning systems. There were also global heat waves in July and August. In some regions, they are also continuing in September and October. There is currently a global heat wave going on in Japan. As I've already spoken, there's a record low sea ice extent in Antarctica, and this is all due to El Nino and global warming. There was also monsoon mayhem in India. There were flash floods in states like Himachal Pradesh in July, August, and September. And these flash floods basically devastated a lot of regions in Himachal Pradesh, where actually new hydrological systems had been created because of this extreme rainfall that happened over the past 2 months. There was also an interaction of western disturbance with the monsoon during the season, and this is a very rare. Down to Earth had done a cover story in February, basically linking the fact that western disturbances are coming less frequently in the winters and more frequently, which increases the probability of them interacting with the monsoon system and making these extreme weather events happen more frequently. So extremely difficult to predict and extremely difficult to forecast. And that is why designing early warning systems around them is challenging. I'll talk about two case studies that we looked at. One was a GLOF event that happened in Sikkim, and the other was the flash floods in Libya. The GLOF event that happened in Sikkim and the flash floods in Libya, both of them, the people who were going to be impacted the most did not get in both those events. They were cascading events, as in the initial event happened somewhere else, and that impacted the river flow and basically collapsed. For instance, both in the case of Sikkim and in the case of Libya, dams collapsed, and it was a cascading event. But those events, the triggering event or the cascading event, did not provide any early warning for the communities downstream. So in Sikkim, South, which is one of the most vulnerable in region, that was basically that was basically keeping the water from coming downstream, basically collapsed, and it collapsed because of general wear and tear that had happened. there was an early warning system that had been established. There was a very basic early warning system that had been established by the Sikkim State Disaster Management Authority, but that didn't work. And there was no early warning that was provided to the communities downstream, and that is why a lot of people lost their lives. The Indian Army lost a lot of its ammunition. And in Libya, the same thing happened. Hurricane Daniel, it was extremely difficult to predict it because it formed due to an atmospheric blocking system, which I will be talking about in a little more detail later. But it happened because of an atmospheric blocking system, which are extremely difficult to predict. And later, when the storm system hit Libya, it generated floods, it created lakes and rivers, and it collapsed two of the dams, which are very old, which were built in 1970s. And none of these two events basically generated any kind of early warning for the people to evacuate. And Sikkim, in the case of Sikkim, hundreds of people lost their lives. And in the case of Libya, thousands of people basically lost their lives. So this brings us to the fact that there's not much of early warning systems in the global south, especially in Africa and Asia. Not many people, not many countries are basically covered by these early warning systems, as can be seen from the infographic. And there are many challenges to basically designing and implementing these early warning systems for different kind of extreme weather events. For instance, for the heat waves, it is very difficult to know the exact impact of heat waves on a particular country, on a particular region, unless and until you know the exact impact of heat waves on a particular region. It's very difficult to design early warning systems and disseminate communication to people when these heat waves occur. GLOF, we don't even know how many glacial lakes are there in the Himalayas. We don't know how many of them are exactly vulnerable to GLOF type events. And only when we know that, we'll be able to design certain systems, put in some certain sensors on water levels and on the collapse of moraine dams, which are basically holding that water in the lake. And we don't even know how many of these are vulnerable to GLOFs right now. A drought, we have certain systems, which I think Giraj Amarnath will be talking about in certain detail. Floods, we have certain systems, which he again will be talking about in detail. Cyclones, India and a lot of countries which suffer from tropical cyclones all around the world have designed certain systems which are decent enough to be able to tell you what the track of the cyclone would be, where the cyclone would make landfall, and what would be its intensity in terms of wind speed and rainfall. But there are certain things which we don't know about. For instance, there are a lot of cyclones, a lot of tropical cyclones, hurricanes, and typhoons, which are undergoing rapid intensification, which means that they gain more than 56 kilometers per hour wind speed in a matter of 24 hours. There are certain systems which have gone from cyclones to category 5 cyclones and like category 5 hurricanes in a matter of a day. And we are not able to predict. We can't predict that because we don't have enough data. We don't have enough observational data from sea surface, from subsurface, which are essential for designing early warning systems for these tropical cyclones. And this has been highlighted to us by experts. And more observational data and more basically cooperation on this data is required among countries which suffer, which are at risk from these tropical cyclones. And we have to basically design systems around that. There's also the Arctic jet stream, which is basically Arctic is warming at a rate much higher than the rest of the world, 3 to 4 times. Scientists differ on what exactly is happening there. But there were global heat waves in July. All of the northern hemisphere and parts of the southern hemisphere went through heat waves at the same time. And such events, such global events, are going to become much more common because of the rapid warming of the Arctic. And these events have to be predicted much before that they happen. and early warning systems have to be designed around the prediction that would be done. Sir, I'll leave it here, and I think we can go to Dr. Mukhopadhyay and Dr. Aman.
Thank you, Akshit. I think Akshit's presentation shows us precisely where we are factually. And now I request Dr. Parthasarthi Mukhopadhyay. As I told you, he is a senior scientist with the Indian Institute of Tropical Meteorology, but he will he deals with how to actually forecast and send that early warning system. So, Dr. Mukhopadhyay, we have also getting questions about on this.
Yeah, thank you. Thank you. First, I apologize. I'm traveling, so right now, so there's some background, so, but I'll try, but I don't have I could not, so I will speak physically. And if you permit to switch off my video,
Please do that,
give
Dr.
me a little
Mukhopadhyay.
more band.
Yeah, please do that. Please do that. Switch off your video.
Yeah. So now I listened all of your uh, deliberations very carefully. Particularly, I want to thank Mr. Akshay for writing a very excellent article in the down part, compiling in a very holistic manner all the inputs across the globe regarding the recent episodes of extremes, and particularly the Gulf event that has happened, devastated Sikkim. Having said that, let me come step by step. So, as you all were saying, that the early warning system is a challenge, particularly in the backdrop of climate change, and particularly in the backdrop of enhanced frequency of extreme events that all countries are facing, including India. Okay. Now, one issue I think, and in the
I think something has happened. His connection is snapped.
Richard, I don't think he's online. So should we move to the next speaker and come back?
Yeah. Okay. Okay. If that is, I think we have lost contact with him. Sorry about that. But then, Dr. Amarnath, Dr. Giriraj Amarnath, can I request you to chip in now? And as I have already briefed, he's really working on early warning, both for drought and for floods. And that's a South Asia initiative. It will be great to actually to listen from you how it's being done and what are the messages out of it and how we can upscale.
Yeah. Thank you, Dr. Richard, and also Akshit for inviting International Water Management to present. I hope I'm audible.
You
Yes.
are audible. Yeah.
Okay. So what I do like the title of Akshit was referring about how early warning for all initiative is very, very fundamental while you look at a lot of climate change message he has given, and your opening remark, Richard, on the climate extremes that we haven't even completed the year, the excellent map from Rajit when it comes to monitoring daily. I was just amazed to see the kind of data you are all collecting. I hope NDMA can use this knowledge, because there are a lot of minor, we have different scale and severity of disaster, and often they get unnoticed, and communities who are affected by these extremes never get compensated as well. So it has to be linked to more private sector if these databases are becoming more and more reliable. So my presentation is that I think we talk about at the end of the day, marginal communities, rural systems, they all need to build a better livelihood resilience. And I think without achieving the goals of early warning, we cannot build that. So that's a prerequisites we are trying to respond through this short presentation today. So I just bring different examples to make sure that you all get a good visualization of the work we are doing. One, I think any early warning system need to be known where and how and what scale of infrastructure we need to invest in early warning. So we looked at all the kind of hazard that happens, not man-made really. Most of them are natural water-related hazard, as you can see here. And these observations are very important to look at when it comes to sustainability of land, water, resource management. Early warning is one such elements to that. And I think why we do early warning, because there are communities where they are living in vulnerable hotspots, and without assessing and quantifying its scale and severity, it will be imperative to really plan and respond to better disaster preparedness strategies on that. So we do this kind of assessment in any part of the region. So the presentation was asked to prepare how do you better respond to early warning needs and the gaps the countries are currently facing on. So, like Richard mentioned about many countries do not have early warning. So this is the current status of early warning. What we call is multi-hazard early warning system. While it looks many countries are in blue, there are still not every hazard has been mapped and early warning systems are being operational. While this blue looks, how do you compare between least developing countries that are showing blue versus a developed country? There is a lot more we can make differences between these countries. So there are more countries need to be better prepared. I think countries like India shows quite a reflection that they do have reported that they have a multi-hazard early warning system. But when we look a bit more closer in terms of what really exists in terms of early warning, I think over years we are seeing this early warning has been increased closer to 95 countries, but still, globally how many countries we have, and lot more need to be achieved. That was also Mr. Richard was pointing out. And when you look at regions like Africa, we have only 18 countries have multi-hazard early warning. There are more than 50 plus countries, so nearly 1/3 of the country do not have the capabilities of providing timely early warning for early action. Asia is in better position because we have been investing in technologies, weather forecasts over the years. Many participants are from the region, realize how better we are improving in terms of the technology, the forecast capability, but lot need to be learned and improved from the global south as well as other part of the region. So it's not so promising, but we are improving from 2015 to 2021, nearly doubling our capabilities in terms of reporting of multi-hazard early warning. Now, it looks good, but when you look at how you want to really develop early warning, I think many of you are known without good data, you cannot even establish early warning triggers. So we need to have historical data, and there is a lot of places where you do not have consistent weather station. WMO and many other agencies have reported the lack of hydrological weather station. Weather stations are increasing, but the hydrological stations are declining, which is quite complex and not easy to maintain. And then we do have issues of coverage. While you might see in many tropical regions and humid and islands, every grid looks quite different in terms of weather coverage. So we need to have more spread, and communication barriers still exist in terms of how do you interpret this early warning, not just about the local language, but also taking a decision based on the information. Public still have a perception, let the disaster come to my house, then we can respond to the disaster. So they are not really responding to the public awareness that the government is promoting. There is a more risk perception, capacity building need to be elevated. A resource constraint is always the case. That is why we don't see infrastructure in weather stations Many countries still lack of Doppler radar that can certainly improve the accuracy and reliability of the weather forecast skills. And despite if you can fill 1 to 4, the topic what I mentioned, the governance and coordination is the biggest challenge among any other early warning capability, the fragmented system we operate, and there are also political factors associated. We saw the news around Uttarakhand floods or the cloudburst, glacier, every what we call is a cascaded risk, but we are not really sure how this warning got challenges. And then there are cultural and language consideration need to be looked at. Technology challenges. Today we can develop sophisticated technology. What is the sustainability of that? How do you translate this information through smartphone and internet in a simple way? And last but not least is the response capability. This is very important because information we have, but how do you coordinate and prepare a plan? This is also an important challenge that we need to look at. So each one of that, there are much more gaps any country or other experts can highlight. I feel that these are some of the key areas that every country and the subnational level need to focus on. What I'm going to give you some examples of what we have been doing over 10 years now, what we refer as a South Asia drought monitoring system. I'm not going to give a full presentation today, but why we started this drought early warning is because it's a very important, crucial step in drought preparedness and management plans to be developed based on your information. Many critical agencies are playing a role: WMO, NOAA, IMD, IITM, Numerical Weather Forecast Center. They are very critical to alert well in advance, 3 to 4 months in advance. And then you track on those regions where the drought is going to spiral in the next coming bi-weekly or next 4 weeks. And then look at how the overall sector is going to impact in terms of agriculture, water resource, energy, livelihood sector, all that you need to prepare a plan. And then it's not the plan to just hold on in your office, but we need to designate this to relevant authorities, to communities, the seed buyer, the fertilizer companies, making sure the rural banks all are being well prepared in terms of knowing that. That's how the Ministry of Agriculture is doing in India, likewise in many other countries. So there are a lot of rooms to improve, but early warning is a prerequisite to that. And also we need to strengthen the existing institutional arrangement like KVK, working with state government. There is always delaying the sowing period, changing the crop, subsidizing certain diesel subsidy or energy providing, waive off of certain documents to make sure that the loans have been granted quickly, because financial access is also an important element that this early warning system can play an important role. So we have these technologies that are operational over many years, and we have recently upgraded these technologies to monitor the forecast data daily, bi-weekly, and seasonal. There are scope to improve the forecast skills, and then we have a drought prediction tool. We have remote sensing based drought monitoring, and then we develop a contingency plan. So every district has got a contingency plan, what to be done when the stages of drought is progressing, and what decision support tool can really offer to those village level planning to be done. So it's a very comprehensive tool. We can have a separate discussion around that at some point in time. Then we move into building that capability. We cannot limit ourselves to say early warning is successful in one country, but we need to bring these capabilities to different part of the world. As an organization, we are spreading our work to close to 25 to 30 countries in terms of drought early warning capabilities over the years. Again, these are available in our IMI websites to do that. I just want to highlight this story, how science-based data is very important when we refer drought early warning. This is the map we produced couple of years back, and we visited senior government officials to brief that there is a likely scenario that the drought is going to happen. And we went with a couple of other knowledge products as well. But then there were lack of interest to really look at why triggers have come out while the ground report says something else. But there was not really a big realization 2 months in advance. And we have even provided ground data to show the cracks have come, the chlorophyll contents are changing already in the ground. but there were not really use of these information. And then at some point in time, the government declared 23 plus districts, which you are roughly seeing already this map. And then this really shows there is a sense of more science-based advocacy, and also improving that these data sets become more and more relevant in decision-making process. That realization has to come, because on the one side you invest in infrastructure, but then there is no one is really looking at translating these knowledge products into early action and early finance. That's where I will be showing some of the examples going forward. But on the other hand, we did use the similar product, similar platform, produce these kind of a knowledge product in terms of, as you can see from this is the precipitation based drought index. You see the snow cover, how it is declining. In 2021, you can refer between a good year of a snow cover. And then the government was very quick in this case to have early drought declaration using remote sensing derived data. There are weather stations are quite limited in this region due to multiple issues. And early action was basically government procured the fodder from private sector to provide to all those pastoral farmers to make sure there is no livestock losses, because many of these communities are dependent on livestock. So you can make use of early warning not just for providing bulletin and dissemination, but translating into a policy level decision making process. Similarly, we do have this drought severity at a sub district level, and then we provide a lot of contingency plan, what need to be done from the extension point of view, what intercropping you can do, what supplementary irrigation you can do, what additional fertilizers you can apply. And then there are examples like this when intercropping was applied with limited water, that crops that receive only less water, they were able to provide some good income from this crop. So the lesson is that when you have sufficient time, reliable informations are produced, the next set of value chain partners can use this data to make timely actions around that. Now, moving into the flood side, it was also mentioned that flood is a phenomenal challenges in India and many part of the region. But problem is that we do not have a sophisticated model that can underwrite a product. So while you can invest in technology, we are talking about communities that who loses the crop losses. Now we have a fantastic Pradhan Mantri Fasal Bima Yojana is a crop insurance program. But again, it's a very comprehensive product. But then in a flood peril, the product needs to be can be much fine tuned. That's what we have been discussing with Ministry of Agriculture. As you can see here in this case, we have developed a sophisticated AI-based flood prediction system. We have a flood forecasting skill, and then you can provide these kind of a flood alert, like we are working in Bagmati River Basin with the Mike model. But the advantages is that having this kind of investment in infrastructure, you need to translate into value chain of these data products. In emergency map, providing that to the multi-sectoral institution to make plans for risk management, translate the data with the reinsurer or insurer to develop a new index parametric product where you don't really need a ground observation. So we have tested these kind of a product. This is also globally recognized by the group of Earth Observation as SDG 13 innovations. We have tested this over 20,000 household. Again, we have a dedicated YouTube material which we'll share with you. You can take a look how field non-field driven product you could develop using a parametric product like this. Very briefly on the, you can do many things, but now comes into a major initiative, what we call is early warning for all. So we have this anticipate action program just commissioned last year, bringing down this traditional relief mechanism into an anticipatory mechanism. So what it does is you have better early warning system today because we have improved technology, processing capability, you have trigger data that can be developed, and fundings can be predefined, pre-financing agreement, and the plans can be activated, and early actions can be mobilized quickly with all the level of stakeholders. This is the concept we are trying to develop called AWARE, early warning, early action, and early finance. So we have this full-fledged platform is live and operational for 7 countries now. It comes with dynamic risk knowledge, looking at risk from climate to health, market, nutrition. We have plans developed for individual pilot districts. We have dynamic knowledge on monitoring those observations and disseminating this information for greater understanding of translating early warning to early action initiative. So This is the landing page of that. It provides a greater interconnectedness, real-time information, collaborative platform with all the stakeholder. We want to promote better inclusive governance, and you have ability to integrate with other platforms, so and so. So this is a screenshot of that. So these are some pictures where we are monitoring in countries like Zambia. And this is the alert dashboard that can provide information to those registered users. And finally, you can get these alerts. More screenshots are there, which I'm not going. My last slide is that there's a very promising sign off is happening now under the global early warning, where there is an investment pledge to over $3 billion by 2027. Every nation should have. But there are a partnership that is very critical to look at which countries you need to focus, like I mentioned about how do you empower these billions of communities that needs better finance, better action, not that we left behind them, and more investment is needed. Then we can come up with the greater, the partnership alignment going forward on this global initiative. So thank you again for giving this opportunity.
Thank you, Dr. Amarnath. And it's, I think, a very hopeful presentation. Despite all the glooms and the disasters, this is somewhere I think you presented us a way out. And that precisely what is being spoken about. And in the upcoming annual climate conference, that the conference of parties to be held in Dubai, loss and damage and early warning, these are the two major issues to be discussed. So we have few questions, and Dr. Amarnath, I will direct a few questions to you. And first, let me address this question. Is there any assessment yet of the CAP or Common Alerting Protocol? Messages that the NDMA, I assume that the National Disaster Management Authority of India has started sending, are they reaching the remote areas? So, Dr. Amarnath, will you address this question? Basically, this question is about actually alerting services. You generate early warning, but how to alert and whether they reach or not.
I don't have much knowledge. I'm not in India for several years. I can't speak of how NDMA is operating. So I won't be able to answer to this question.
Okay, so now I'll ask Akshit how it works. Akshit, as journalist and many Indians in the last few weeks received this alert services. Will you take us, Akshit, how it goes actually, whether it reaches or not?
Yes, sir. So basically, it works through this app, mobile app called Sacheth. And apart from that, the Ministry of Home Affairs collects data of all, basically has data of mobile numbers through Aadhaar and everything throughout the country. And whenever there is any kind of, not just extreme weather event, but any kind of disaster, it could be a chemical disaster, chemical based disaster, or it could be a radioactive based disaster, it could be an earthquake or anything like that. Basically, this information goes through the NDMA through the Ministry of Home Affairs, and then it is disseminated through the Sacheth app. And whenever there is any region that's going to be affected by an earthquake, by an extreme weather event like a cyclone, like a heat wave, or a flood, or flash flood, or landslide, anything like that, that particular region gets these messages. And currently, at least, it's through SMS. I think a lot of people who are listening in and otherwise would have gotten these messages from the Ministry of Home Affairs or the NDMA over the past few months during perhaps the Himachal floods, perhaps the floods in Delhi, perhaps even during thunderstorms and lightning. Certain messages would have come in from this app. So even if you don't have the app, you get the messages. But if you have the app, then you can get specific messages and specific information on particular extreme weather events and other disasters that are happening all throughout the country.
Okay. Dr. Amarnath, can I direct this question? Somebody has asked on this, the role of indigenous and the communities in early warning systems. And we have few examples also between India and Nepal. I mean, that's one. Will you just address this question?
Yeah, no, I did put my remarks in the chat box already, but it's very important because communities are the one who is receiving in terms of information, but they are also one of the first end receivers of this disaster itself. So what we generally do is we conduct a community level risk assessment, capturing in terms of the past events, how does it has impacted them, identified the gaps in terms of what informations they need, and then prepare what we call is a SOPs around that, including the early warning framework. So often the communities will be highlighting, they do come with their indigenous knowledge, which we are also capturing, but it has not gone in a very extensive way, like in terms of changes to the early flowering or changes to the birds giving the nesting. There are different examples that the communities do highlight there in their intervention. But more importantly, we also hear those voices and translate into an action plan. This also includes that many of the disaster happens, they are not easily reachable in 2 to 3 days time in many hilly and terrain regions. So we need to make sure that those early action protocols developed based on early warning triggers can be activated remotely, ensuring those cash vouchers are being provided to regions where they can get some food, put them in safer place. So communities do have a clear wish list and their priorities. So we set those elements into our framework. But there are plenty of examples to highlight other than what I just mentioned, Mr. Richard.
Thank you very much. And I'll just quickly touch one questions, rather that's a query, how you assess loss and damages. I think that's the biggest question. The whole world is now talking, and we'll be talking more in the next conference of parties in Dubai also, because that also involves the compensation and also how to actually bring in the things in context of the climate negotiations. But in case of India, we have a very complex, delayed, and you can say that there is not a set method to actually fix loss and damages estimation. So what happened currently? Suppose a flood hits a state, the state gives an assessment. The central government sends a team, it assesses it. Then there is always a time lag of reaching up to the final figure, and the final figure is always there's a huge difference between what the state wants or estimated and what the central team estimated. Then there is a based on that the from the consolidated relief fund the money has to be given. So it's quite a convoluted one, means very complex one. But even how to estimate what is the loss exactly? Suppose in a flood, I have lost crops, I have lost livestock, I have lost house. How a cost to each of these assets is fixed. So currently, the India is actually implementing a new model of estimations. That's mostly UNDP, United Nations agencies, and World Bank have evolved that, and many countries have adopted, and we are doing that also. Otherwise, there is no set method. And you must have seen it. One state will give you certain compensation for certain loss, another state will give you another amount. Even in case of heat wave death, also, if you look at it, most of the states don't offer you anything, but few states do give. Then the question comes how to certify it. So it's quite a, I think it's, there is no method into this currently. But as I told you, yes, we are experimenting with a formatted way of estimating loss and damages in a disaster, and that many countries are adopting that model, so we'll be also doing that. So this is what all about this thing. So basically, just to close it and to sum it up, there is no denial the fact that in the new situations, disasters will be basically that we have to live with, and they will be unpredictable. So losses and damages and how to prepare for that, that makes actually the early warning very critical interventions. So in case of a climate risk planet, it's the mitigation and adaptations also brings in early warning as the third pillar to actually live in a climate risk planet. And as Dr. Amarnath also showed that it is doable, it is being done, and wherever it has been done, we have actually got the benefits. So the casualty wise, the damages wise, as I pointed out, if you don't have an early warning system, your mortality and damages mortality rate will be 8 times higher than a country who has a early warning systems. But we have an immediate target to fill up. That's by 2027, each of us in the planet will be covered with a early warning system. And that's the challenge. And I think in this whole fight against climate emergency, this is going to be the most critical interventions, we have to do it immediately. So again, thank you very much. And all the presentations and all the contact details will be uploaded on it. And Dr. Amarnath's email is being sought after now. So you will get all of them being there. Again, thank you very much for joining us. And we'll continue with this series. Thank you very much.
Thank you.
Thank you.
Thank you. Bye-bye.